Assalamu alaikum, sir. Today I will explain my DLC assignment named Digital Parking Control System Project. It counts car entering and exiting in parking garage. When full, it shows full on display. If space is available, it blinks space available. Now the first question is about block and flow diagram. The part asks for a step-by-step plan to design the parking system. We need to draw diagram showing how the counter, sensor, and display work together. Here is the block diagram. The block diagram shows how all the parts of the parking control system connect and work together. It starts with a keypad to set the maximum parking capacity. Here, 6 cars. The entry and exit sensors feed data into a 3-bit up-down counter which keeps track of how many cars are in the garage. A comparator a comparator checks if the current car count matches the maximum capacity. If the garage is full, the timer 1 triggers full. The timer 1 activates the full display if the space are available. Timer 2 triggers the blinking space available display. Next, the flow diagram also includes essential components like an encoder, register, and a clock to synchronize operation. Each block has a specific role, ensuring the system accurately monitors parking space and updates the flow of data control signals between different parts of the system. For the counter design in question, a 3-bit up-down counter is used to count up to 6 cards, which requires three JK flip-flops. Each JK flip-flop toggles based on the clock and the previous state, enabling synchronous counting. Now the question to focus on 555 timer duty cycle on segment display to recognize it's about circuit design for the parking display. The question required to design two separate 555 timer circuit to control two different display behavior. The first circuit continuously display the word full when the garage is full. For this, I use 555 timer in a stable state when it keeps the output high at all the times. The second circuit controls the blinking display of the message space available when there is parking space. This timer need to blink the message based on a calculated frequency. I used D where A plus C plus D plus E plus F into T equals to 40. So the duty cycles become 60%. The capacitor of 250 microfarad is best choice from given capacitor. This capacitor provides resistor values easy to obtain and safe for the timers. It achieves the required 60% duty cycle and R values matches the desired frequency 5 Hz on average timing of 120 millisecond on 120 millisecond on and 80 millisecond off. The 470 The 470 microfarad for low resistor drawing too much current and 50 microfarad show very high resistor. Now the third question is about FSM and HDL code. This question requires a state machine design to control the display output and its Verilog code, ensuring if it follows given time limits. The FSM has to clarify. The FSM has to clearly define states. State A where output A is active for a duration TH equals to 4 millisecond, and state B where B is active for TL is equal to 4 millisecond. I created a state diagram to visually represent two state transition and a state table that defines the current state, next stable output A or B, and counter values required for state transition. To implement the FSM, I wrote Verilog code with a state register and a counter. The next state is determined based on whether the counter has reached the value of TH or TL, switching between states A and B. The output is simply as design A when in state A and B when in state B. The counter resets on every state transition, ensuring precise timing for each output period. The question 4 is about limitations and upgrades. Finally, we analyze the system's weakness like small capacity and suggest improvement like adding microcontroller for larger parking system. Limitations. The 555 timer control or enable signal, making it unsuitable for dynamic digital control. The current counter is limited to handling only up to 10 cards. And the third point is the system does not support real data logging or remote monitoring capacitor. Now how to make the system better. Replace the 555 timer with microcontroller or FPGA for better timing control and programmability. Install spot sensors. Integrate sensor with a microcontroller to add features like data logging and LOT-based monitoring. To use the system in larger parking areas, we need to add more sensors and split the area into zones. Each zone have its own sensor and display. We should also use a central system to manage all the zones together. This way, the system can handle more cars and give better control and information without getting confused or slow. Thank you, sir.